Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to electric vehicles and hybrid electric vehicles. In this particular tutorial, we will be looking into the implementation for proximity pilot and how it works in coordination with control pilot. So basically, we will be covering the control pilot implementation post to this proximity pilot tutorial. So as we already seen this circuit for the proximity pilot, how the proximity pilot works, what is the basic circuit that is there for the proximity pilot. So if you see, this is the proximity pilot connection, which is the pin 5 to 5. So this is the charging port pin, and this is the electric vehicle inlet that you have. So this is the charging connector, and this is the vehicle inlet, and you also have this is the charging controller, and this is the vehicle controller. Here you have the power supply of 5 volt for the proximity pilot, and you do have 330 ohm resistance, 2.7k ohm. So these two are present on the vehicle side. If you see any charger, then you will have a handle. In that handle there will be a switch. So that switch is this one, which is the S3. So if it is pressed, then this particular resistor will get sorted, and if it is not pressed, then it is not sorted, and basically the the driver is not holding the charger. And we do also have a 150 ohm resistance that is connected. So overall circuit, how it looks in the flow like this, which is basically a kind of voltage divider circuit of 5 volt with multiple resistance into account. And this is how the entire flow of current looks like in this case. So this is the basic diagram for a proximity pilot. Now let's jump into the model implementation for the same. So we will be considering those elements which we just seen now, and we will try to develop the proximity pilot model. So if you see here, we have this proximity pilot model here present, and we do also have the control pilot model present here. So first we will see and have a look into the implementation for the proximity pilot. Once this proximity pilot sends a response like the charger is connected, then you can see that signal is getting communicated to the control pilot that the charging is happening, like the charger is getting connected, and then only the proximity, then the control pilot will give the signals that are responsible for controlling the current or for charging the battery. So such way. So if you see here, there are multiple inputs that are present. We have given two constant blocks for every operation. So the first one is the charger not connected. So in this case, the charger is not connected, that is showing it as 0. If the charger is connected, then it will be 1. This is all about the charging port, but we do also have a handle switch that we discussed. Whenever the handle is being pressed, it is 0, and whenever the handle is not pressed, then it is 1. So pressing means opening the circuit, and not pressing means it is closing the circuit. So that's why it is little bit swapped logic. So opening circuit is 0 and closing circuit means 1. So that signal is going in, and what we are getting, the control pilot response. So basically the voltage levels that we discussed in the last tutorial, and it will not be the exact voltage, but it will be nearly the same voltage near to the ideal condition, because as we already know, like most of the conditions are not ideal in a practical scenario. So while implementation, we need to take that thing into consideration. So let's jump inside the proximity pilot subsystem. So here you have all the stages that is being described. So charger not connected, which means the voltage level will be 4.5. Charger connected, handle is being pressed, then in that case you will be having 3 volt. If the charger is connected and handle is not pressed, then you will get 1.5 volt. Now if you see, this is the voltage source we connected, and we need to connect it to the ground also on the other port just to close the circuit. So all these are connected to the ground as well, so that we are closing the circuit. And if you double click over here, we see the amplitude of the voltage that we are taking as 5 volt. as mentioned in the circuit. Here, this is the 330 ohm resistance which we have. This is connected in series. For switching, we do use a thyristor in this case, and whenever this gate signal is 1, then this will get closed. This switch will get closed. When it is 0, then it will be open, and that way we will be controlling the connection between the charger and the electric vehicle. So if it is 1, then in that case charger is connected. If it is 0, then it means the charger is not connected to the vehicle. We also have this part is the EVSC part, or the charger port part. So we can see there are two resistors in this case, 150 ohm and 330 ohm resistance. And also we do have one switch additional here for representing the, so if it is pressed, then we will be getting 0. If it is not pressed, then we will be getting 1. If it is not pressed, that means we will not close the circuit over here, and we will be considering the resistance. If it is closed, then we will be considering, we will not consider this resistance. So in this case, this is representing the handle input. Let's see like how the input looks like and how the output looks like. So this is the entire voltage divider circuit, and we are manipulating and connecting multiple components, and along with that we are taking some readings. The reading will be taken mostly as output from this level. So you will be getting the voltage difference between the main line and the ground, and that voltage will be considered as the proximity pilot voltage. So if you go outside, then we will be doing now the operation. So the first operation is charger not connected, handle not pressed. So in this case, you will be getting a 4.5 volt output, 4.45 basically, which means it is not connected, charger is not connected, neither the handle is being pressed. Charger is not connected, and we will be pressing the handle because we will be removing the charger from the charging port, and we will be pressing the handle to put it inside the vehicle. So in this case, you will be getting this voltage 2 point. So this will be mostly approximately around 3 volt. So here you can see 3 volt represents charger is connected, handle is pressed. So in this case, the charger is connected. So it is 1, and handle is being pressed. Okay, so you are getting this 3 volt as the output. Now next is the charger is connected and handle not pressed. So at that moment, now handle is not pressed, we need to switch this. So we will be switching, and then we will be getting a voltage of 1.5. 1.5 represents the charger is connected totally. So here the proximity pilot is sending a signal true, which means once, and that is getting communicated here in the control pilot, and the control pilot will be taking now further action. And this is how we can implement a proximity pilot just in a MATLAB environment. And we can see here the charger status, connector status, and also the handle status as the input, and we are able to see the proximity pilot output voltage response, and through that we will be signaling the control pilot that we are connected, now ready to control. So coming to the overall video summary that we have, so here we implemented the proximity pilot implementation, and where we do need two inputs. One is the charger connector status, and along with we need also the handle status. So with this, what we are able to do, we are able to achieve multiple voltage levels through the implementation of the circuitry, which we seen already in the PPT here. So this is the part. Along with that, we also see, so with this, we've seen the inputs, the outputs, and how the voltage levels are getting controlled. We will see in the next video how this control pilot works with the same concept of implementation. We will first refer the implementation diagram, and then we will see how the MATLAB model is being developed. We will have a deeper look into the same based on the voltage levels. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. Have a great day ahead. Thank you, and happy learning MATLAB.